The subject matter of response surface methodology is new to the students in the postgraduate course, because right in the undergraduate course they get to know the linear models, all the standard varietal designs, CRD, RBD, LSD, also a little bit of factorial, the way we have tried to understand here in the form of recapitulation, but this topic is not quite covered there. So it has got three terms: response, surface, methodology. So methodology to understand the surface of the response. You have a response variable y, and the response, you are trying to explain the nature of the response through a study of the model. The model envisages y as a function of the covariate or the regressor. Typically we call regressor, the kind of regression model, y equal to alpha plus beta x. But if there are more than one regressors, it will not be just like y equal to alpha plus beta x, it will possibly be y equal to alpha plus beta 1 x1 plus beta 2 x2. Even one can go beyond, like y equal to alpha plus beta 1 x1 plus beta 1 1 x1 square plus beta 2 x2 plus beta 2 2 x2 square plus beta 1 2 x1 x2 and so on. One can go up to any degree for both of them, or one can truncate one and extend the other. All kinds of things go on. One can have even a general number of more general number of regressors than just two, and there could be any number of regressors coming up. And when we look to the nature of the model expectation of y in terms of this explicit function of the regressors, it describes what is called a surface. So we are trying to understand the nature of the surface underlying the response in terms of the explanatory variables or the regressors, and the methodology to do that is embodied under the framework of response surface methodology. I won't be able to get deep into it. I'll only tell the basics, and then in the next three modules, starting with this particular module, module 20, and I hope that should be a good understanding about the topic, and then if it is taken up in postgraduate course, then the students should be able to take up from the basics that I am taking up there. Hopefully it should be okay. Sagorika, as I said, this is the last topic that we are going to take up, response surface methodology, RSM in short. I plan to discuss again in terms of MCQs this topic. In essence, as I said in the introduction, it deals with regression setup, but with more than one regressor or more than one covariate. The regressors are also the response, they are all assumed to be quantitative in nature. Okay. The response variable is y, which is quantitative. The regressors x1, x2, etc., they are also regarded as quantitative. Further, the nature of regression goes beyond linearity to quadratic or higher degrees. Normally in our undergraduate course we learn about linear regression, quadratic regression, etc. But that involves only one regressor, alpha x, alpha plus beta x plus gamma x square, etc. But here we are talking about more than one regressor simultaneously acting on the response, and the regressors may have degree beyond the linear. Okay, so we mostly focus on quadratic regression involving a number of regressors in this setup. Okay. So without any loss of generality, every regressor we can assume, because it is quantitative, we can assume that it takes values in the closed interval -1 to 1. Okay. The idea is, if any regressor x is in the closed interval a to b, then x minus a over b minus a, that is the standardized version, that is between 0 to 1. Yes. So 2 times this thing will be between 0 to 2, and then 2 times this thing minus 1 will be between -1 to 1. So x can be converted to u, which is 2 times x minus a over b minus a minus 1, and that u will be between -1 to 1. Okay. It is in that sense that any covariate, any regressor in a closed finite interval can be linearly transformed to another related covariate which will take values, regressor, which will take values in the closed interval -1 to 1.
Okay.
So there is beauty in making this kind of transformation, that once you do it, then the regression of y on all the regressors can be studied by using this uniform domain of the regressors, namely each one is between -1 to 1, no matter what their original units are and what their original ranges of variation are.
Okay.
So this is how then this unification is made right in the beginning. Okay. And the purpose is to study the pattern of the response surface, as it is called, in terms of regressors. The idea is that y is a function of all these regressors. All the regressors are in the closed interval -1 to 1, and we want to examine the behavior of the response pattern on the behavior of y as a function of all these xi's. That is called understanding the response pattern or the response surface. That's the whole idea. Apart from fitting the mean model, the main focus has been on its attaining the maximum as well. Where does the response hit the maximum? Can we get a good prediction for the point, for the combination of the regressors which will provide maximum of the respondent, that means y, the response variable. And can we hit upon this point of maxima with utmost accuracy? These are some of the important issues that have come up in the study of response surface. But anyway, we have to understand the basics, namely how the parameters are estimated, what are the properties of so-called good designs, and how does one decide about choice of a design, and so on. But we will be taking up some related concepts in the process as well. So with this general introduction, let's take up some conceptual questions involving the RSM, again mainly in the form of MCQ.
Okay, sir.
So please start reading.
Okay. So the first one is RSM deals with symmetrical factorial experiments or asymmetrical factorial experiments or linear regression or none of the above.
So far as we have understood response surface methodology, it is concerned with an understanding about the response y in terms of the regressors going beyond linear regression. And the regressors, there is no question of factorial experiment here. Straight away you are looking to the regression model. Therefore, the answer to this question should be D. Next one.
The next one is RSM deals with linear regression, quadratic regression, polynomial regression, or none of the above.
If we are talking about response surface methodology, then the first thing we have to understand that it's not one regressor or one covariate. There are a number of regressors acting on it, and they could have a quadratic effect, polynomial effect. Okay, so here also the sense that is carried in this question too, in the options given, looks like you are talking about only one x, y equal to alpha plus beta x, or y equal to alpha plus beta x plus gamma x square, or y equal to alpha plus beta x plus gamma x square plus delta x cube, etc. When you are referring to polynomial regression, the sense is always in terms of y and x, which is not the case for RSM. Therefore, answer still should be none of the above. Next.
So here is the next one. RSM deals with technique for studying the response pattern or this A in the presence of explanatory variables or polynomial regression or none of the above.
So you can see that amazingly we are slowly and slowly heading towards the definition, the closest understanding about the definition of RSM. And the first two questions are like that. Now we are slowly heading towards that. It says technique for studying the response pattern, yes. A in the presence of explanatory variables, yes, because here the concept of regression is coming. Polynomial regression, none of the above. So closest answer is B, which says the technique for studying the response pattern in the presence of explanatory variables. What is question 4?
So here we need to know that RSM deals with either linear regression involving multiple response, or it might be quadratic regression involving multiple response, or linear regression involving single response, or none of the above.
let's try to understand the response surface methodology. We are talking about a number of regressors, but the response is always single. Y is not a vector. Y is single response coming out of a combination of the regressors. Okay. So multiple response, that is not the issue here. Issue is just single response. Only thing is that how are the regressors they are acting on the response. So in this case, the closest example is none of the above.
Yes.
Next.
So here we want to know that RSM deals with either technique for studying multiple response or technique for studying qualitative response, or it would be for quantitative response, or none of the above.
Here the closest answer is C, as you can see, technique for studying quantitative response.
Study.
Next one.
Here again we want to know RSM deals with either technique for studying single qualitative response or technique for studying single quantitative response, or it's a technique for studying multiple quantitative response, or none of the above.
So as we are saying repeatedly, Y is the single response based on a combination of the regressors. It is never multiple quantitative response. So the closest answer is B, which says that it deals with techniques for studying single quantitative response. Okay. Next.
So here we want to know that RSM deals with either technique for studying response in the presence of explanatory variables, or technique for studying qualitative response in the presence of explanatory variable, or studying quantitative response in the presence of explanatory variables.
So the best answer here is option C. It says that it deals with techniques for studying quantitative response in the presence of explanatory. Those are the so-called regressors.
Yes.
Okay, next.
Here the four options are, the question is RSM deals with technique for studying linear regression in the presence of exactly one covariate, or it might be a technique for studying linear regression in the presence of multiple covariates, or quadratic regression in the presence of covariates, just covariates.
And none of that. Okay.
Yes.
When we talk about RSM, we don't know how the surface goes. The nature of the surface is totally unknown. We cannot say it is linear, we cannot say it is quadratic. It is true that it is a technique for understanding the nature of regression, the nature of the effect of the covariates on the regression, on the response Y. But you cannot specify it like this or that. So here the closest answer is none of the above. We have to go further. Next.
Here RSM deals with technique for studying single response in the presence of covariates. It's a technique for studying single response in the presence of qualitative covariates, or in the presence of quantitative covariates, or none of the above.
So the closest answer is C. Technique for studying single response in the presence of quantitative covariates. Okay. Next one.
Here again it's a technique for studying the response pattern in terms of explanatory factors, or it might be in terms of characteristic being studied, or it's a technique for studying quantitative response pattern in terms of quantitative explanatory variables, or none of the above.
So ultimately we can see that it is heading towards the precise definition. Option C tells you it is a technique for studying quantitative response pattern in terms of quantitative explanatory variables. This is the closest that can come. Okay. Very good. Next.
Here in RSM we are concerned with study of response pattern in terms of explanatory variables, or study of response pattern in terms of explanatory variables when response is qualitative, or it's a study of response pattern in terms of explanatory variables when response is quantitative, or none of the above.
So you know the answer now. The best bet is C.
C. Yes.
Naturally, yes.
So the next one is, in RSM we are concerned with study of response pattern in terms of explanatory variables, or it's a study of response pattern in terms of explanatory variables when both response and variables are qualitative, or it's a study of response pattern in terms of explanatory variables when response is quantitative but explanatory variables are qualitative and none of the above.
There, of course, we are deviating from the definition. So naturally, none of the above. That is the best thing. Okay.
Yes.
Next.
So the next one is in RSM we are concerned with study of response pattern in terms of explanatory variables, or it's a study of response pattern in terms of explanatory variables when both response and variables are qualitative, or it's a study of response pattern in terms of explanatory variables when response is quantitative but explanatory variables are qualitative and none of the above.
There, of course, we are deviating from the definition. So naturally, none of the above. That is the best thing. Okay.
Yes.
Next.
Here again in RSM we are concerned with the study of response pattern in terms of explanatory variables, or in terms of explanatory variables when response is qualitative, or it's a study of response pattern in terms of explanatory variables when both response and explanatory variables are quantitative.
That's the best possible answer.
Yes,
Okay.
yes. Here again in RSM we are concerned with study of response pattern in terms of explanatory variables, or in terms of explanatory variables when response is quantitative. And the next one is it's a study of multiple response pattern in terms of explanatory covariates when the response is quantitative. And
Yeah,
none
you are
of that.
saying repeatedly why the response that is single.
Yes.
No matter how it is influenced by a collection of regressors, but it is always a single value quantity. Okay.
So C can't be
C
the
can't be the result. Okay. So here it goes through none of the above.
Okay.
Or it could at most be B.
Yes.
It could at most be because it refers to quantitative response.
Yes.
Okay.
So here
15.
is the next one. In RSM we are concerned with the study of response pattern in terms of explanatory variables, or in terms of explanatory variables when response is qualitative,
Ruled
or study of response pattern in terms of explanatory variables irrespective of the nature of response.
That is also ruled out.
Ruled out,
So here
yes,
it is
and
none of the
none of
above.
the above,
Okay.
yes.
Next.
Here in RSM we examine the response by classifying it into several categories, or by modeling it in terms of explanatory variables, or by approximating it in terms of explanatory variables, or none of the above.
We are trying to model the response in terms of explanatory variables. Okay.
Okay.
Y equal to etc. That's how we are trying to model it.
Okay.
So that is the best possible answer. Okay.
Here the next one is in RSM we examine the response by classifying it into several categories, by modeling it linearly in terms of explanatory variables, by approximating it linearly in terms of explanatory variables, and none of the above.
In response surface, we never talk about linear. We have to go beyond linear to be able to see the surface well.
Okay.
Therefore, the result here, the ideal response should be D, because you should dig more into the nature of the response. Okay.
So
next.
none of the above is the correct answer.
Yeah. Yeah.
Here in RSM we examine the purpose by
The response.
response by classifying it into several categories, or by modeling it as a polynomial in terms of explanatory variables, or by approximating it as a polynomial in terms of explanatory variables, or none of the above.
Yeah, we don't know the exact nature of the response. All we are doing, we are trying to model it, or we are trying to approximate it. They both mean more or less the same thing.
Okay.
Therefore, we are trying to approximate the response as a polynomial in terms of explanatory variables.
Okay.
So, B or C, those are the closest answers. Next.
So here in RSM we examine the response by classifying it into several categories, by modeling it in terms of explanatory variables irrespective of their nature, by approximating it in terms of explanatory variables irrespective of their nature, and none of the above.
No, it cannot be irrespective of their nature, We are trying to understand the behavior of Y as a function of x1, x2, etc. So, unless there is a regularity in the behavior of Y, we cannot get anything out of it, if there is a erratic behavior. Therefore, irrespective of their nature, it cannot be.
So, here is another one.
Okay.
In response surface methodology, we examine the response by classifying it into several categories
Okay.
or by modeling it in terms of explanatory variables which are assumed to be quantitative in nature, or by approximating it in terms of explanatory variables which are assumed to be quantitative in nature, or none of the above.
Yeah, we are trying to model the explanatory variable, the response, or we are trying to approximate the response in terms of the explanatory variable.
Okay.
Now, the difference between modeling and approximation, if it is a mathematical entity, we can try to approximate.
Okay.
But if it is an uncertain thing, because of the error creeping in, we try to model. So, more appropriate is modeling rather than approximating.
Okay.
So, I think with that all the RSMs are over. Now, I still want to tell something more to you. So, let us see. I want to discuss some properties of the regression designs for our understanding of the response surface methodology, with special reference to efficient estimation of the parameters of the mean model. Mean model means expected y. So, leaving aside the epsilon part.
So, so far it has been very interesting indeed, and relatively easygoing and highly fascinating. I hope this time it will be a bit technically involved.
Yes, you will see some technical matters involved in the nature of regression designs with some salient features. Yeah, Sagorika, in this module 20, we dealt with very superficially about some aspects of the response surface methodology, what it deals with in terms of the response variable, the nature of the response variable, the nature of the explanatory variables, how many and each one is of what type, and how many data points are needed, everything in a sort of non-technical or semi-technical way. But this subject matter is also thoroughly researched and documented. There are many technical things. We will have a test of those things in the next two modules as we proceed. But this one was very basic in our understanding of the response surface, which is mainly an extension of what we know as the regression models, but applied to a single covariate, applied to a single response variable, and a number of explanatory regressions. Sagorika, before closing this module, let us take up some theoretical questions and MCQs.
Okay, sir.
Let me read out question number 1. Write a short introductory note on RSM. Explain the context and the purpose of studying RSM. So you should try to read some textbooks as well, this book by Dasandagiri, as I say. You can see the historical account and why study of regression is very important, why the response surface, because it involves more than one explanatory variable.
Okay, sir.
Very important, and then whatever you have understood so far, the nature of the study, etc., you can write a short note.
Okay, sir.
It may be non-technical at this moment.
Okay, sir.
The question number 2 is, how do you think one should proceed to study RSM when there are two versions of a qualitative feature involved in the study? Take, for example, both male and female categories in a study of health data. So let me explain. You are having health data, and then there are a number of covariates like height, weight, blood pressure, this, that, etc. There is a key response variable, and there are a number of regressors.
Okay.
And you have data for both males and females. You are talking about study of response as a function of the covariates, but then there are two versions of the qualitative features. Namely, it could be for males or it could be for females. How do you study the response surface methodology?
Okay.
That is the problem here.
Yes, sir.
The some parameters will be common to them, some parameters will be special for either males or females. So taking care of how to take care of those parameters in the model itself, that is what you are supposed to explain. Okay. The third question is, a study involves 4 quantitative variables, each with a quadratic effect on the response pattern. So there are 4 quantitative variables, regressors, each one with a quadratic effect on the response pattern. Examine the implication of this phenomenon on the number of distinct data points needed to observe the response. Let me explain. So you have the response y, and there are 4 quantitative regressors, each with a quadratic effect.
Okay.
So let the regressors be x1, x2, x3, x4. So you are trying to model y as a function of these 4 regressors. Each one has a quadratic effect.
Okay.
So y should be equal to alpha plus beta 1 x1, beta 2 x2, beta 3 x3, beta 4 x4, that takes care of linear. Beta 1 1 x1 square, beta 2 2 x2 square, that takes care of the square part. There could also be beta 1 2 x1 x2 going up to second degree, second degree and so on, etc. Second order or second degree, there is a confusion between order and degree. First order means what and second order means what, first degree means what, second degree means what. Those questions will come up at the end. Okay. So at this moment you are talking about the quadratic regression. Each one has a quadratic effect. So you try to understand the formula for the model expectation of the response variable.
Okay.
And then from there you have to identify what are the number of parameters involved, because the number of data points will depend on the number of parameters because of the question of estimation of the parameters in the model.
Okay.
So you have to have as many data points as there are number of distinct parameters in the model.
Okay.
And then the question is, what is the implication of this fact, this modeling, on the number of distinct data points needed to be observed. So you have to spell out what is the minimum number of data points where you have to observe the response y. This is a good problem from technical point of view.
So
Let's see, please read.
The first one says, a study involves 4 quantitative variables, each with a quadratic effect on the response pattern. The number of distinct data points needed to observe the response pattern depends on which of the following. The first one is the nature of their individual effects, like linear or quadratic and nothing else. The second one says the nature of their pairwise effects besides individual effects. And the third one says the nature of their all possible joint effects. And the fourth one is none of the above.
Okay, so there are 4 quantitative variables. We are denoting them by x1, x2, x3, x4. Each one has a quadratic effect on the response pattern. So if you are talking about x1, it should be beta 1 x1 plus beta 1 1 x1 square. Similarly, beta 2 x2, beta 2 2 x2 square. That we can see. But apart from that, do we still have x1 into x2, x1 into x3, all the cross products, all taken 3 at a time, all taken 4 at a time? That is the issue.
Yes.
Okay, that's the issue that they are trying to bring about. So the more you put, the more you get a good manifestation of the response, that is true, but then you are inviting more parameters, therefore more data points as well.
Okay.
So one has to understand what is the implication of this and how far one should go in terms of writing down the model.
Okay. So here is our next one. A study involves 4 quantitative variables,
Okay. Almost the same background,
each with a linear and quadratic effect on the response pattern. And the number of distinct data points needed to observe the response pattern cannot be determined unless all 4 of them have the same nature of effect, like all linear or all quadratic, or the nature of their pairwise effects will also is also known. The nature of their all possible joint effects is also known. And finally, the study involves several locations.
Okay. So first of all, there are 4 quantitative variables like x1, x2, x3, x4. Each one with a linear or quadratic effect, we can go up to quadratic.
Yes, sir.
So the question is whether we are talking about terms like x1, x2, x1, x3. That's the main issue. Now A says all 4 of them have the same nature of effect, all linear, all quadratic, that is not needed. The nature of their pairwise effects is also known. If I know it is x1, x2 and x1, x3, whatever terms are there, if we know, it is good to know that so that we can find out how many distinct data points are needed. The nature of their all possible joint effects, they are talking about whether it is x1, x2, x3. Terms like x1, x2, x3. Yeah, the more we know about the nature of their joint effect, we can do a justice on the number of distinctive data points that are needed.
Okay.
But the study does not have to be carried out in several locations. No, that's not needed.
Okay.
So it looks like the best answer here is C. The nature of their all possible joint effects is also known.
Yes. So here is the final.
Okay.
Here is the third one. Our study involves 5 quantitative variables,
Okay.
each with a linear or quadratic effect on the response pattern. There is also a qualitative feature with 2 options like males and females attached to this study.
Okay.
Now, the number of distinct data points needed to observe the response patterns cannot be determined unless all 5 of them have the same nature of effect, like all linear
As you know,
or
that's not
quadratic.
needed, okay?
Okay,
That's
yes,
not
yes,
needed,
sir.
okay.
The nature of their pairwise effects is also known for either males or females. The third one is the nature of their all possible joint effects is also known for both males and females. And finally, the study involves several locations.
The
as
most
well.
plausible answer is C. It is talking about the possible joint effects of all the 5 quantitative variables, quantitative measures on both males and females. Well, that will give maximum information on the model part, and hence we can find out how many distinctive data points are needed. Okay. We need more information on the nature of the surface.
Okay.
That is coming out of the option C.